Hi student, how are you? Hope you fine and good. Your teachers they all hug. Okay, in this video we are going to study more about Turk and their direction on rotation. Like what is the meaning of net Turk and direction of rotation. So let's see. Like if we have a lever and if there are more than one force is applied, let's suppose one is downward, one is upward, so in that case we will find the total of these two turn, like one is downward, one is upward. This is called net or total torque, mean net or total in the direction of rotation. And direction of rotation mean it is going this force is more or this force is more, or this distance is more or this distance is more. If you find the torque, so you will find the direction of rotation, or it will goes downward or it will goes upward. So okay, let's see. There are some turn which is produced because of the this force, or mean there because of the torque. Okay, the first one, the net torque or total. Net mean total in the direction of rotation. Okay, there are some property here. Let's see. The direction of rotation of net torque mean total torque about the axis is found by the adding individually rotation of the direction. First let's see these two property, then we will do some example in this video, and also will give you some homework. Okay, the first one, remember one thing, when we apply the force on lever here, mean this direction or this means same, this is same, like this one or this one. The next one is, let's suppose if we apply the force on this one or in this, so this is also same. So when the this lever, if we apply the force, and because of this force there is produced the turn in this direction, mean in this, so this is called clockwise, or sorry, counterclockwise, and or anti-clockwise. We will also say anti-clockwise or counterclockwise. So if the force produced the turn on anti-clockwise direction, mean this direction, so we will put or measure this direction positive. Or if the force produce the turn in this direction, like if we produce the force in the force produce the turn in this direction, so this is called this direction, like mean the upward direction is called CCW, or counterclockwise or anti-clockwise. We can also use anti-clockwise. Or downward direction is called clockwise. Okay, the clockwise must be negative, like downward is negative but the upward is positive. Okay, the simple example how we know the clockwise or counterclockwise or anti-clockwise, like when you see the watch, like this 1 2 3 and so on, so there are three needle. So when the normally the needle is moved in this direction, this needle, like this is the, let's suppose watch 10 9 8 7 and so on, this is 6. Okay, when the needle is moved in this direction is called clockwise. But if we apply the force, but forcefully, when we move this needle on this direction forcefully, so this is called anti-clockwise, mean in this direction is called anti-clockwise but the normal direction is called clockwise, or this is normal is clockwise but this direction, opposite direction, is counterclockwise or anti-clockwise direction. So let's see here, like this is the rotation point of this lever. Here are two forces applied, F1 and F2, and the distance from this point, turning point, to the applied force is D1, and the distance from turning point to the applied force is F2. So two forces applied, but both are counterclockwise. So we know that we will calculate this one is positive. So total torque will be T1 plus T2. Why? Because of this will give us T1 and this one is give us T2. So T1 is equal to F1 multiplied by D1 and T2 is equal to F2 multiplied by D2, and both are in same direction, so we can find the addition of these two. Okay, and the other hand one is counterclockwise and the other one is like this is F2, this is F1, this is clockwise, so this is negative and this one is positive. So then we will minus the second one, like if we find the total torque. So first this is the total torque, so if one like this one T1 is coming down, goes upward, so counterclockwise, and this one is negative direction, produce the torque in the negative direction or clockwise, so we will minus the second one, the torque 2 from this one. Hope you understand. Okay, let's see on the next page. We are going to solve some example of this one. Okay, they ask the question, find the net torque here. So let's see first, this is the turning point. How many distance or how many force we have? Let's suppose this is equal to D1 and this one, this is 2, so this is equal to D2, and the last one is equal to the whole distance, this is equal to D3. Okay, let's see, the two forces are in the same direction, so if we want to find the T net, so we do this is in the same direction, T1, this is T1 plus T2, and the last one is downward, so directly find the negative, so this one is T3. Okay, let's write the formula here. T1 is equal to 10 Newton, D1 is equal to 2 meter plus T2 is equal to 25 Newton multiplied by D2 is 2 plus 2. We will count these two distance. So 2 plus 2 is equal to 4 meter, and then negative sign, and the last one F3 is how much? 5 Newton, and the total distance 2 plus 2 4, and after this 4, so multiplied by 8 Newton. So 4 plus 4 is how much? 8 meter. So 10 multiplied by 2 is 20 Newton meter plus 25 multiplied by 4, it's 100 Newton meter minus 40 Newton meter. So this is equal to 120 Newton meter minus 40 Newton meter. So when the total torque which is produced here under what direction? So 120 minus 40 is equal to 80 Newton meter. So this is equal to under which direction? Look at this one is more than like the counterclockwise is more than clockwise. So we can write plus R CCW. So this is the T net on the system. Okay, let's see on the next page. I will give you some homework. Hope you try to solve this question. The properties used, you will find this one. You will find the net torque. There are 3 different directions. Angle is also used. This one is also used, and this force is also used. So every force is its own distance, is also its own value. So you can find the net torque here. This is your homework, and also on the next page this is also your homework. Try to solve these two questions. Like the total distance of the lever is 70 centimeter, and here the force is applied 10 Newton, but the angle is 40 degree, and here is also applied the force 15 Newton. Here is also applied the force 20 Newton, and the angle is 30 degree. And also, so you can use the clockwise, anti-clockwise, and the property of the Turk, and you can find the total Turk. But if you have any question and if you have any problem in this question, so you can ask in your comment. But first try to watch the previous video, and also the previous question that I solved already, so you can find the solution or you can solve this one very easily. Okay, thank you so much, dear student. If you have any question in this 3 lecture about the Turk, so you can ask in your comment. Thank you so much.